This team of pioneering shipbuilders is embarking on an extraordinary project. They are racing to build the ultimate cruise ship, a £360 million superliner that will be more opulent than the Titanic.
Well, I wanted to build something unique, one of a kind, never to be repeated again. The most luxurious cruise ship ever built.
Today's cruise ships are part of a long and historic tradition. Long before the aeroplane, ships were the only way to travel the world. Today, they carry thousands of holidaymakers. This new vessel is designed to attract the world's richest travelers. A night in its most luxurious suite will cost £8,000. The stakes for the ship's owners couldn't be higher.
Anytime you raise the bar, there are risks. Because, quite frankly, shipyards are accustomed to building, let's call them Chevrolets. And this is a Rolls-Royce.
Constructing this new vessel involves a series of unique engineering challenges. The ocean can be a dangerous place. They must keep hundreds of passengers safe, sailing far from shore through violent storms and rough swells. And to complete the ship on schedule, the team must combine time-honored tradition with trailblazing technology.
To build a ship is a continuous pressure. We cannot miss our target.
This is the story of the race to build the ultimate cruise ship. Today in Genoa, Italy, this team of construction workers is starting work building a brand new ship. One that will present a new and difficult set of challenges, both technical and artistic. For the team here is constructing a ship they hope will set a new standard in luxury cruising. In keeping with maritime tradition, a welder attaches rare coins to the hull to bring luck.
That's a beautiful thing.
And a priest provides a blessing. Engineers in this region of Italy have a formidable reputation. They have been building ships for hundreds of years. But this job will present new challenges beyond anything they've faced before. The worldwide cruise market has exploded over the past 25 years. From under 4 million passengers a year to over 22 million today. It is now a £32 billion a year industry. Competition is fierce, with companies building ever larger vessels to drive prices down and make cruising more affordable than ever.
What I would like is, since there are 2 decks, give me a deck in the painting, give me a deck in the pastels. Okay. And then some of these wide ones...
But one cruise company and its CEO, Frank Del Rio, are taking their new ship in a different, more risky direction.
They're all vertical. Like right here, this is a nice triptych that I'd love to see in pastels.
Oh, okay.
My vision is very simple, to make this the most luxurious cruise ship ever built.
So we can plot this out.
Yes, ma'am.
The new vessel will be called the Seven Seas Explorer. Designers will fit out the ship with hundreds of crystal chandeliers, An acre of marble, gold leaf-embellished mirrors, and 400 custom-designed place settings. The average cost of a suite on a 2-week cruise will be £10,000. But is there a market for this? Many of the big cruise ships hold over 5,000 passengers. This vessel will carry just 750. But they will be paying top prices, and their expectations will be equally high. The guests will be housed in 374 suites, and at the top will be a 400 square meter penthouse that will cost up to £8,000 a night. Frank Del Rio is counting on there being enough people willing to pay these colossal prices.
There is risk anytime you break barriers, but these are calculated risks.
This ambitious scheme is not just a business challenge. It's an engineering challenge for the ship's designers and builders. First, luxury is heavy. The vessel's marble and glass fixtures and fittings will add weight. Engineers will need to invent clever ways to balance the ship so it remains stable in the water. And there's another, even bigger challenge. Keeping passengers safe. Without making it too obvious, engineers must devise ingenious ways to deal with emergencies. From a fire on board to a collision at sea. And there's a final challenge. The engineers must meet a tight deadline. To fill the ship with customers, tickets for the maiden voyage will go on sale before the liner is complete. Cancelling the trip would be extremely expensive.
That would cost us in excess of $5 million to the immediate bottom line, and probably cost us $25 million in lost reputation. So an expensive proposition that we won't let happen.
In Italy, it's the job of engineer Pierluigi Ponta to deliver the ship on schedule.
I am very proud to be in charge of this project. Several thousand people will be involved, but I will coordinate all the activities from the starting of the design up to delivery. I hope to survive.
The pressure is on Pierluigi and his team to turn these sheets of steel into a finished ship. Pierluigi has an ambitious plan to ensure they meet the deadline.
Consider that this is the most luxury ship ever built. We have to be very careful and precise on the installation and construction process of the ship.
He will build this ship piece by piece in a dry dock, installing the engines and machinery as it goes. To save time, he must simultaneously construct a large section of the vessel in another shipyard, making sure it will join up perfectly to the rest of the ship. Then the shipyard will build up the decks to complete the hull, put in the cabins, fit the windows, and install the navigation equipment. To ensure it all works, they will test everything in a series of critical sea trials. Finally, they must fit out the interiors of the cabins and public areas. It's like building a floating city. And they have just 18 months to do it. In Genoa, Pierluigi's team has started work constructing the Explorer. Once the shell of the ship has been built, designers will need to fit out the vessel's marble and glass interior. Stage 1. The team must cut and weld together more than 12,000 tons of steel to assemble the liner's hull. To build the hull in time, the team will employ an ingenious technique. In the past, ships were constructed from the bottom up, a bit like building a house. Only once the hull was finished did they install the ventilation, electrical cables, pipes and machinery. But this method was slow. Too slow for today's competitive environment.
To build a ship is a continuous pressure. We have a penalty on the contract about the delay on delivery.
So to build the new ship's hull, Pierluigi is using a technique developed in Japan in the 1950s, made possible by the invention of bigger, stronger cranes. Workers will first assemble the steel plates into sections 1 deck high, building them upside down to make it easy to install the pipes, cables and ventilation as they go. Cranes will then flip the pieces over and join several together to form a mega block. It will take 53 mega blocks to construct the Explorer. Once each block is complete, giant cranes will lift it into position. Using this mega block method, the team can work on many parts of the ship at the same time, speeding up production. The steel begins life in a giant bath. Here, a computer-controlled plasma cutter cuts the steel to shape. The machine's nozzle fires a jet of superheated gas towards the steel. This melts and cuts the steel underwater, which keeps it cool and prevents distortion.
The plasma perfectly cuts the plate's edges.
Next step. Workers weld the steel sheets together to form each mega block. It takes about 4 weeks to build each of the 53 mega blocks. This method of construction is fast, but not fast enough for the schedule. So Pierluigi has a plan to speed up construction.
We decided to build part of the ship in another shipyard to reduce the production lead time and to take advantage of the capacity of the 2 shipyards at the same time.
While the shipyard in Genoa is building most of the vessel, a large section is being assembled 400 miles away at a second yard in Castellamare di Stabia. This shipyard sits in the shadow of Mount Vesuvius. It has been building ships for hundreds of years. Over the last 8 months, the workers here have assembled 11 mega blocks to form this 60-meter section of the ship. It contains the main entrance foyer, a major focal point for the design team.
This is the heart of the ship with the panoramic lift in front of us. And here the guests will have their first glance at the ship. The stairs line up on either side of this big hall, and along two nice curves, they come here on the main atrium. This is the space from which passengers start flocking through the other areas. Main dining room on that side, theater on that side, and of course upstairs to all the other rooms in the ship.
Workers will fit out the ship's interior in Genoa. The team here must now move their section 400 miles up the coast. A daunting challenge. First, they must launch their section into the sea. Then a tug will tow it up the coast to the shipyard in Genoa. Welders must then attach it to their section of the vessel. If Pierluigi's plan to build the ship in 2 places works, it will cut 8 weeks off the construction schedule. Before they launch the section, surveyor Antonio Vero must carry out one final check. For the last 8 months, he has been measuring the dimensions of this piece.
We are measuring the length of the section to verify that it matches the plan's dimensions.
The section must be within 5 millimeters of the planned size, or it won't join onto the rest of the ship.
It is essential because if what they've made in Genoa and what we've made here do not match, this will cause serious problems later.
The shipbuilders here are also concerned about the launch of this section of the liner, because sliding it down this slope into the sea is a risky maneuver. In 1907, another Italian shipyard proudly launched its new ship, the SS Principessa Giolanda. She slid smoothly into the sea, then promptly capsized. The shipyard had somehow neglected to install any stabilizing weight in the bottom of the hull to lower her center of gravity. Here, they're not taking any chances.
We have to put some water inside the ballast tank in order to be sure that the ship will be in a safe condition when she touches the water.
To prevent their section from capsizing, the workers here have built it with a heavy, double-bottomed hull and installed water and fuel tanks low down to ensure that the vessel will be completely stable when launched. Today, they will use a proven ship launching method that dates back to Roman times. Workers cover the slipway with a thin coating of hot wax. Then a layer of grease to make sure that the section of ship doesn't get stuck. The stage is all set for the next day's launch. "8 a.m. 3 hours to launch. A team of workers starts driving wedges under the keel. The aim is to lift this section of the ship just enough to free it from its supporting pillars so it can slide into the water.
The scope of hammering the wedges is to transfer the ship weight on the central sledges. In this way, it will be much easier for us to remove the side pillars. It's 10:20. We are going to remove the last two pillars, and so we are almost ready to go.
The only things now holding the section of ship are 6 steel claws that will be released by hydraulics. Tension is building. Following ancient tradition, a godmother launches every vessel to bring it luck.
Marina, in nome di Dio, taglia!
There's no engine or rudder on board this section of the ship. So the team is counting on 165 tons of chains to slow it down and stop it from ploughing across the harbor and smashing into nearby boats. The weight low down in the hull keeps the section upright.
It was a very positive day. We have the weather on our side. Now we have a sunny day, so everything was good.
Tugs must now haul this empty section 400 miles around the coast to Genoa, where the team will find out if it fits to the rest of the vessel. The journey should take 4 days, but any storms or swells could delay its arrival and the race to complete the ship on time. In Italy, construction workers are racing to assemble the Seven Seas Explorer cruise ship. Once the shell of the ship has been built, workers must fit out its interior suites, restaurants, and install the swimming pools. In Florida, CEO Frank Del Rio is on a mission to buy artwork to decorate the finished vessel.
For example, I love this new piece that you just did. You know, a little gold, little blue, a diptych like that. And sometimes...
Frank needs to source artwork that will live up to the expectations of wealthy clients.
I'm doing a puzzle here. Architecture defines the ship. Art brings it to life. We actually need pieces for the public bathrooms.
Okay. Oh, wow.
And these are large pieces. So this is a rendering of what these bathrooms look like. So they're very, very high-end, all marble, all granite. I mean, how many bathrooms have you seen with chandeliers? On deck 4, we need 4 pieces. On deck 5, we need 7 more. On most other vessels, art is an afterthought. It's background noise. So for a vessel of this size, to spend $7 million on art is unprecedented. Look at the colors, the boldness, the reds, the golds. I think this will work really well in the men's room. Here on deck 5. I feel pressured to pick, and pick quickly. I have thousands of art pieces to buy. Thousands. I like this one. This one. I want to put this on the wall. Like these. Yeah. I don't like this one.
Do you like the brighter colors, the yellows at all, for anything?
I like that yellow, but just mix it up. Your goal is that this art is so incredible that people want to go to the bathroom. All right?
Frank commissions 8 of Andre's paintings, but his mission is far from complete. He must source up to 5 original artworks for each of the 374 suites. The biggest suite will be a 400-square-meter penthouse, situated at the top of the ship.
So this is the living room area?
It will aim to offer the ultimate in cruise ship accommodation.
This will be the bar area, right? And then we move to the indoor winter garden that will extend all the way to the edge of what appears today to be the balcony. What a beautiful view. And inside, I think this is the bedroom area where we are here. Seating area. And then the bed itself.
With the bed alone costing £120,000, this room is a big gamble for the ship's owners.
So this entire space is bathroom and closet. It's unbelievable. Have its own sauna and wet room and a jacuzzi, right? The jacuzzi is in this position. That is beautiful.
At £8,000 a night, this suite is reserved for the super rich. In Trieste, marine engineer Gianpiero Lavini is figuring out how to propel the completed vessel through the water.
One of the main targets is to get a very, very comfortable vessel, completely silent and free from any kind of vibration.
The vibration must be low enough to qualify the vessel for a standard known as comfort class. To power the ship through the water, 4 massive 8-cylinder diesel engines will drive 4 generators. These will supply electricity to electric motors that will turn 2 huge propellers, pushing the ship forward at over 20 knots. The design of the ship's propellers is critical. If Giampiero's team gets it wrong, the ship could vibrate violently.
When you are at sea, if you have any type of troubles, you cannot take any action because you cannot modify the propeller. It's absolutely impossible. So you'd have to know everything in advance.
In 1907, during the sea trials of British ocean liner the Lusitania, at that time the world's biggest ship, the vibration was so bad they had to strengthen the interior in a failed attempt to stop it. The problem came from the ship's propellers. When a propeller rotates, it can create areas of low pressure on the back of the blades, causing water to form bubbles of water vapor in a process called cavitation. When the bubbles burst, they collapse in microseconds, sending powerful shock waves through the water and onto the ship's hull. This creates uncomfortable vibrations for people and objects on board.
Cavitation is the worst enemy of a propeller designer because it is the main source of noise and vibration. So I'm not satisfied till I have removed every bubble.
To prevent the ship from vibrating, Giampiero must minimize the cavitation on the propeller blades. The simplest way to do this is by slowing the propellers down. This reduces the area of low pressure that causes bubbles. But this would also slow down the ship. So to compensate, they will make the propellers bigger and add more blades. The special propellers should give passengers on board a smooth ride. The ship's propellers are being cast from bronze at this factory in the Netherlands. The task requires extreme precision. If workers here don't reproduce Giampiero's design to within a fraction of an inch, the propellers could still generate vibrations. They feed his plans into a computer that will carve a mold in sand bonded with resin.
We are able to accurately create a shape by a grinding of the sand mold, and all the material that's not needed is cut away so that we get a precise shape that we want it to be.
From the resin-bound sand, the machine must first carve the base of the mold, then make 6 blade-shaped pieces to form the top, leaving a propeller-shaped gap. Workers will place this mold in a steel frame, add a system of tubes to pour in the molten metal, then cover it with sand to prevent the top of the mold floating when they fill it. The foundry will cast the propeller from a special bronze alloy, a mixture of copper, nickel, and aluminium.
The alloy that we use is actually called nickel aluminium bronze, and it's very corrosion resistant, and it's a strong material, so it's quite suited for ship's propellers.
But the size of the special propeller creates problems.
It's a big propeller. It weighs, when casted, about 30 tons.
To avoid serious imperfections that could create vibrations and affect passenger comfort, they must fill the mold in one continuous pouring.
What's special for this project is that we use two ladles at the same time to make sure that the mold is filled at once.
Using two ladles speeds up the pouring process, helping ensure that when the mold is broken open, the propeller will contain no serious imperfections. It takes less than 3 minutes to cast the propeller, but it will take 3 weeks for it to cool and harden. At the shipyard in Genoa, Pierluigi and the team are anxiously awaiting the hull section from Castellammare.
Today is an important day. We are going to join the two big sections. As soon as the section coming from Castellammare is arrived, we close the gate of the dry dock and we start to empty the dry dock.
Pierluigi won't rest easy until he knows that the two sections are joined.
We don't have the plan B because only the A can exist.
But bringing them together in this narrow dock will be a challenge. The dock's width restricts the size of tug they can use to pull the section in. And if the tugs lose control, gusts of wind could blow it off course and send it crashing into the dockside.
Oh!
The tugs struggle to wrangle the flailing 3,300-ton section of ship through the tight entrance. Once they've placed the section safely in the dock, the workers close the gate. To join the two sections together, it's critical that they are aligned precisely. As the water drains, they will winch the Genoa section into position. It sits a meter lower in the water than the newly arrived section because it contains the ship's heavy engines. As the hull drops, divers will guide its marker pegs into sockets fixed to the dock floor. Once it's firmly in position, the team will winch in the section from Castellammare, line up its marker pegs, and let the draining water lower it precisely into place, ensuring that both sections are perfectly in line. At least, that's the theory. Lowering the first section into position is the easy part. Lining up the new section from Castellammare will be more difficult. 4 diesel-powered winches enable them to maneuver it with precision. Steel guides lead it into its approximate position. But guiding the marker pegs into place underwater needs an expert eye. A diver will help the team line it up precisely.
Matteo, quanto manca all'imbocco della forchetta? Ok, più o meno 65.
They restart the pumps to lower the second hull. This will be the moment of truth. Will the two sections fit?
Ok, piano piano sta andando, va bene.
The diver shows them they are out of alignment.
Come prima, 2 centimetri. Siamo perfetti.
After some maneuvering, the alignment is looking better.
Now it's in place.
It fits. Both sections of the hull line up perfectly. With the vessel's structure nearing completion, the race is now on to fit out the interior. But luxury is heavy, so the challenge for the design team is to create a decadent interior without unbalancing the ship. In Genoa, work continues on the ship's construction, while across the Atlantic Ocean in Coral Gables, Florida, another team is designing the fittings for the vessel's suites, dining rooms and lounges. Johandel Ruiz, lead designer, must select all the materials for the internal spaces. But designing a ship's interior presents a unique challenge. Luxury items like stone floors and marble walls are heavy.
Weight is one of the biggest concerns we have on board a ship, so you try to put the majority of your weight in the lower decks. If you're doing stone floors, you will limit the amount that you will use on the upper decks, just to prevent the ship from listing. So as you go higher on the ship, you tend to use lighter, more airy materials.
But Johandel will have his work cut out for him. The most expensive suites on the vessel, full of stone and marble, will sit right at the top of the ship. They must make sure they don't jeopardize its stability. If they put too much weight high up, it could lead to disaster. In the summer of 1915, the American ship, the SS Eastland, with 2,500 passengers on board, was about to set off for a pleasure cruise on the Chicago River. After the Titanic disaster 3 years earlier, government legislation had required the ship's owners to install more lifeboats on the main deck. Unfortunately, the extra weight of the boats made the Eastland top-heavy and unstable. Before leaving the harbor, it rolled over and capsized. 844 passengers and crew died. The passenger death toll was even greater than on the Titanic. At the shipbuilder's headquarters in Trieste, Michele Moro must keep a detailed inventory of the weight of every object on board the Explorer and where it sits on the ship.
We have inside about 20,000 items.
From lifeboats to champagne bottles, pianos to plates.
This is the description of the item. This is the position of the deck. We have the quantity. This is the kilos.
A computer plots the location of every object to calculate the stability of the ship. To position the most expensive and heaviest suites high up, Michele has worked out that they must cut tons of weight from elsewhere. Instead of the original vision of glass balconies, designers must now use lighter steel railings. The ship's funnel will no longer be steel, but an aluminium alloy, which weighs half as much. But that's still not enough. Johandel needs to find a way to slim down the fixtures and fittings without compromising on luxury.
What we decided to do, you use a honeycomb system similar to what I'm holding here. So half of the panel would be a marble or a granite, and then it'll be back to a honeycomb made out of aluminum, and it'll keep it very light and airy. As you can imagine, 52 suites times a lot of marble equals a lot of weight. So making small changes, including this, we've been able to reduce the weight quite significantly.
In the Netherlands, the ship's propeller has cooled and been released from its mold. Now workers must grind its blades to their precise shape.
They have different tools to grind away the material. They start with the coarse grinder, and afterwards they will get to the finer grinder.
These grinders shave off a thin layer of bronze on each pass. It's highly skilled work. Any unwanted bumps left on the propeller's surface could cause the ship to vibrate and jeopardize passenger comfort. And if they damage it, making a replacement from scratch will take months and delay the maiden voyage. In Genoa, over 1,000 workers are now racing against the clock to finish the ship in time for its maiden voyage. In the space of 4.5 months, cranes winch the mega blocks forming the upper decks and the aluminium funnel into position. 42 mega blocks are now in place, leaving only 11 to install. It's beginning to look like a ship. To deliver the vessel in time for the first passengers, 8 months from now, work on the ship reaches a fever pitch. Teams of electricians, fitters and mechanics cram nearly every space. Power supplies fill the dockside. More than 40 miles of cables feed electricity to the welders on board. Outside, a team of painters is transforming the ship. Once at sea, microorganisms attach to the ship's hull, making it less streamlined and slowing the vessel down. This increases fuel consumption, a penalty that must be avoided at all costs. The solution lies in the paint itself. When the ship is in motion, the paint releases chemicals which kill the microorganisms, keeping the hull smooth so it can glide through the water with minimal friction. It's taken 1,500 workers 9 months to assemble the mega blocks, install the electrical and ventilation systems, and paint the steel structure. But there's still a huge amount of work to be done on the inside. Next time, a team of designers, carpenters, and decorators transform the steel shell of the ship, fitting it out with fixtures and furnishings. And before she can carry passengers, the vessel must pass a series of critical tests at sea. It's a race to complete the ship in time for her maiden voyage.
His life wasn't always as glamorous as his flamboyant wardrobe, yet he set the world alight with his music, discovering the man behind the sign in brand new The Prince Story. Icon, genius, slave, Easter Sunday at 9. Next tonight, highlights from the Championship, football on 5.